Sorry for the delay, but we had some problems with the laptops. But now everything is fixed. So I'm going to give you a really short presentation, a really brief one about the general information about the course and about the project. And then there will be another presentation from TV and Julia into more details for the first part of the project. Okay. So we're going to talk about general information, about deliverables, so which are basically just presentations, it's nothing to deliver. And then how to use the Moodle, and then short project description, and then some description about the different software we are going to use for the project. So basically the grading method of the course is an oral exam, 20 minutes for each student. The first 3 minutes are for the poster presentation, so you have to do a poster. Each one has a different poster about the project. And then there will be questions on the project from the professor, and also questions on the theory of the course. And then there is the group project, which is not graded, but is a mandatory things to do if you want to do the oral exam. Okay. There will be so the students. The groups are 6 students for each group. There will be 5 presentations during the semester, but each group has to do only 3 presentations. We will assign the presentation to each group during the semester. But generally speaking, everybody has to do the first presentation, which will be in the 5th week, and the last presentation. While the other 3 presentations in the middle, we decide during the semester who does what. Because, I mean, we still don't have the final number of students in the course, so we still don't have the groups, we still don't know how many groups there will be, so we will decide, like, probably in a week or 2, we will tell you which presentation you have to do. And then there will be a final report about all the project, and you have to deliver the final report 10 days before the exam. So for the presentation, the first 3 are shorter than the others, and normally in each presentation you have like 1-2 slides, and then you have to present those slides in 2-3 minutes, and then you will have some questions from us and from the professor, and also people in the students can ask questions. And since you have like 6 students for each group, and there will be 3 presentations, so it means that 2 students has to present every time, and you have to change so that everybody present once. And basically 2 students, 1 present, and then they will answer the questions together. They can help each other. And the slides has to be uploaded in the Moodle before the lecture starts. So you will find a link in the Moodle where you can upload your slides. So this is the timeline with all the deliverables. You will see basically with all the presentations. So here, you will see there the presentations, and this is the topic of the lecture, and that is the topic of the lab. So it's really important for us that you follow the Moodle and that you actually kind of read it every time, at least once a week before the lecture, to see what's the topic of the lecture, what's the topic of the project, and you can download all the materials that you will need, like project descriptions or slides or whatever, the notes from the professor, whatever you need. And there are also all the informations about the installations of the software, like Ample, and other software like Bells in Valley or whatever, how to use the virtual machine, this kind of stuff. So it's really important to go through the Moodle. Here is the link. And basically the Moodle is completely done now. So you have all the plan for each lecture from now to the end of the course. So now we can discuss a bit about the project. So basically, as Francois told you already, the PFL has a kind of old heating system to supply it to the different buildings. There are 24 buildings, and you have some of those buildings which are connected to a high temperature loop, which is like 65 degrees C, and one at a lower temperature, and some buildings at a lower temperature loop, which is around at 50 degrees C. So what you have to do basically is to try to renew this heating system of TPFL, taking into account different objectives, like there can be like minimization of CO2 emissions, or minimization of energy consumption, or of the total cost, or whatever. So you will have to study different scenarios, okay, at the end of your project. So this is the current energy system of the TPFL for supplying heat. So basically, as I told you already, there are two temperature loops. The red one is 65 and the orange one is 50. And then you have like two ammonia-based heat pumps, which are these two here, one for each loop. And then you have two oil-fired gas turbines, one for each loop as well. But it's kind of old, and we need to change it. So the project is divided into 4 parts. The first part, it's about the analysis of the demand of each building, and also the construction of the typical periods that you will need into your linear problem to solve with EMPO, right? So here is this part here, it's the first box at the top left. And in week 5, you have presentation. So here is a kind of map to sum up everything. And then in the second, the second part will be about the MLP, which stands for Mixed Integer Linear Programming. Okay, so here you have to solve a linear problem, and in this part you will have to implement linear models for each energy technology you need to implement inside the model. Okay. And here, week 7, you have the presentation, which will be the second one, and then you have. So basically, you will solve this problem using EMPO, right? Which is a programming language which is really high level and is used to solve this kind of large scale problems. And you will in the first part, basically, in the second part, it will be only linear problem, while in the third part there will be no linear problem. So here you will need to study 3 different possibility of recovering energy, heat from 3 different things you will see in the description, which are there. And here you will have to apply the same language to a nonlinear problem. And week 9 you will have the presentation. And then in the last week, not last week, but last part, the 4th one, you will have to learn how to use Bells Valley. So Bells Valley is a flow sheeting software that is used normally to do data reconciliation. But in the next slide, I will talk a bit more, even though just one slide, about those software. So what is important is that every part of the project is linked. So basically, the core part is the linear model, which is done in EMPO, right? And then you will have to feed to this model all the results from each part of the project. For example, here you will, from this part, you will get all the heating demands of all the buildings that will be used inside the linear problem, okay? The linear model. And then here it's about the implementation of the different utilities, right? That will be used here also. And here it's a no-linear system in which you will analyze 3 different scenarios. And then the results of these scenarios, that will be, for example, the temperature at the inlet of the heat pump, or some heat recovery potential, will be also fed into the linear model, okay? And the last part, basically, you will use some real data coming from like the double-stage heat pump of the PFL, to calculate, to reconcile measurements, and to calculate the performance, like the efficiency of those of this technology. Right? In this case, a heat pump, but you will also study, for example, a gas turbine, and from that you will get the turbine isentropic efficiency. So that in the first stage you will assume this kind of parameters, while at the end you will calculate those parameters from a real case. Okay, and then at the end, you should come up with a model, which is, for everybody should be the same, and with all the results from each part of the project. So basically, as I told you already, discussed a bit about Ample and Melting Valley, but we also provide you with virtual machines in which you have already all the software installed inside, not Ample actually, but you will have both MATLAB if you need it and Melting Valley. Ample we provide a way to download it and to install it into your laptop. Actually, you can already start doing that if you want, because in the Moodle at the top of the page of the web page you have already all the zip files from which you can install. And it is important to know that basically we assign one virtual machine to each group, and we cannot control how many people of each group are actually connecting to the virtual machine. So it's recommended that each group connect only in one virtual machine at a time, right? Because we have fixed limited number of virtual machines. And if 6 people in a group all connect, it means that some other group will not have the virtual machine available. And okay, so Ample already said something. As I said, it's a mathematical computing language to model this kind of problem. And it can handle both linear and nonlinear variables together with binary and integer variables. And then Melting Valley is flow sheeting. It's called flow sheeting software, which is basically an equation-based data validation and reconciliation software that uses real measurement coming from real plants and use these measurements to like reconcile, because as you know, like each sensor is affected by some errors, right? And this error can be big sometimes, especially when you are like at a shutdown of a plant or there is a plant failure. So you need to make sure that those those measurements are reliable enough to like calculate efficiency or to calculate performance. And this kind of software are really used nowadays in real cases. For example, they're really used in upstream refineries, petrochemicals, chemical plants, and also in a nuclear power station, in which you know that actually reliability in the measurement is essential. So, okay, this is just an introduction to the software, but you will see them later in the project. Okay? You have questions? Yes, please?
So the Ample software will only be available on the virtual machine?
No, the Ample is not available. It's the only thing that is not available in the virtual machine. You will have it, you can download it at the top of the web page in the Moodle. You have to choose your operating system. You download the zip file, and then you have like a README file which is written how you have to install it and how to start up. And actually, there is also a video that I did last year, which is about the introduction of Ample, and it's also in the Moodle at the top. And in which basically I'm explaining a bit the basic commands in Ample that will be useful for you during the project. Not all of them. I mean, there are a lot of stuff, other stuff, but the basic things that you will need for the project. Other questions? If you don't have questions, TV and Julia will start with the first part of the project. Thank you.
So, welcome everyone to this first part of the project of the modeling course. So my colleague Julia and I, we are going to present the beginning of this project. So as you know, and as Alessio has said before, this project is divided into 4 parts. So the objective of this presentation is not to give you all the information that you need for the complete project, but rather to give you some overview about like a specific first part, which is about the development of a building model. If you have any questions during the presentation, please feel free to ask. So this project deals with the energy demands of the EPFL campus. As you have seen before, like the EPFL campus has a heating system with a different number of heat pumps and a different number of heating systems. And this project that you have like 3 weeks for is divided into 4 main tasks. The first task is about estimating the heat gains. The second task about the calculation of the properties of every building that you will have to analyze. The third task is about calculating the heating demand per hour. So we will give you like some data for a complete year, and then applying some equations, you will be able to calculate the heating demand for every hour. And finally, because it's a lot of data, we will ask you to simplify the amount of data that you will get and that you will simplify into like typical periods. So let's imagine that you have like a building. Technically speaking, you have like different sources of gains and losses. So one of the gains that you have, obviously, is like the amount of heat that you get from solar radiation. You also have some additional heat that is coming from all of us. So these are like the internal gains, like the radiation from our bodies. But you also have some internal gains that are related to the use of electricity in the building. So for example, the computers, the lamps, different utilities. And obviously, we have like some heating losses in the process. So we are losing some heat by ventilation, for example, because we need to refresh the air in the rooms. But we also have like some heating losses because of the temperature difference between like the inside of the buildings and the outside. So the aim of the first task, of the first project, is to actually calculate how much heat you are getting every day, every year, every hour, from the sun and from the people who are actually on campus. So in order to do that, we will give you like some information about like the number of people, like the surface of the buildings, how much sunlight you're actually getting per day. So for example, as a simplification, we consider that you have people at EPFL only from 8 to 6 on a weekday. So we assume that there is no one in the weekend and that you don't have the need for any kind of heating system. And at the same time, like the lamps, the computers, they are on more or less at the same time. You actually have like the computers and the lamps on from 7 to 9 p.m. So for example, this is the occupancy profile. So you can see that the buildings are divided into like 3 categories: offices, vacancies, and the classroom. And these are like the amount of heat that you can actually expect from like the electronic appliances, depending on the type of building and depending on the hour of the day. So all this data that I'm giving you right now is actually available on the Moodle. You have the irradiation data, and you also have like a file that is in MATLAB in order to know exactly how to call the data from the Excel files.
Actually, I have the PowerPoint.
Oh yeah.
Okay. Okay, so the second task of this project, after you calculated the heat gains, is actually the calculation of the building envelope properties. So each building has some properties based on the material it's built of, based on the age and everything, that defines the heat transfer between the building and the outside. And this heat transfer is characterized by the K thermal, which represents the thermal losses of the building, and the K sum, which is the thermal gains that the building has from radiation of the sun, basically. And the objective of this task is here that you will find the Ks for each building that your group's assigned. In order to do so, you will get an equation for the thermal loads of the buildings that is a function of the Ks, and also the heat gains that you calculated in the task before, and the temperature profiles of over the year that you'll get. And then the approach on how to do that is basically that you will have 2 equations, because you have 2 variables, right? You have 2 Ks, so you need 2 equations to solve it. And the first equation is defined by the state that you have heating demand, so you switch on the heating of the building, meaning that K thermal, as you can see here, is either bigger than 0 or smaller than 0, heating or cooling. And the second equation that you'll get is defined by calculating the yearly heating demand, which is defined as the sum over the max function of the Q thermal, which is the hourly demand, and 0. Meaning that we only consider Q thermal when it's actually bigger than 0. That means that cooling in this case is not, we don't consider cooling basically. So we only consider heating demands. Okay? If this doesn't seem super clear to you right now, that doesn't matter. All of this is also available in the Moodle in the project description. The presentation's online, we are here. So this is really just an overview of what it's gonna look like, a really rough idea. And then you have these 2 equations here. And in order to solve that, you're going to apply what Francois talked to you about this morning, which is the Newton-Raphson method, which is a numerically approach to solve nonlinear equations. Okay? And those are the things that you will implement in MATLAB in order to get the two Ks. And I mean, the material you have I already mentioned with basically the PDFs that you have in Moodle, the MATLAB code we will provide to you, a basic MATLAB code in which we have already some suggestions on how to solve this. And also, yeah, I thought you picked that up. Also, we are here to help. And then, once you have the case, the next task, the task 3, is the calculation of the hourly demand, for which you can use the same equation as before. The Q thermal is a function of the case, the heat gains, and the temperature. And now you have all that information, so it's basically really easy to just plug all the informations in and calculate the hourly heating demand.
So once you have like a heating demand not of a complete year but per hour, the objective is to actually simplify this data. So for example, if you plot the heating demand against like the time, you will probably have something like that. You will have like a lot of fluctuations over the days and over the year. So let's imagine that you want to treat this data afterwards, that you want to do an optimization, for example, for knowing which kind of heating system you want to implement. This is obviously like a lot of numbers if you consider all the buildings, the 8,760 hours per year. So what we need to do out of that is that we need to simplify this data. So instead of considering like all the variations, we will consider that maybe we need only like 5 or 6 typical hours, typical periods that will represent the heating demand for the complete year. So for example, you can see with this graph that you have like 3 different red lines, you have 2 green lines, and you have 1 blue line. So these are examples of like what you would call like a typical period. So you make the assumption that, for example, between 8 a.m. and 10 a.m., you will have like a heating demand of 20 megawatt hour. In practice, it might vary between 22 and 18, but what is actually important here is to simplify the data so that you can process it afterwards. So there are different ways to do it. And one way that is perfectly valuable, for example, is to consider like 1 day per month, and then you analyze the heating demand for this specific day. And then you compare like the data that you have, for example, in February or that you have in December. And obviously what you have like in summer, so for example in July or in February, in the winter time would be quite different because you have like differences in terms of the solar irradiation and the external temperature. So there are like different methods to do it. And the aim of this specific task is that you apply like different methods that are like described in the description of the project, and that you find out by yourself like which solution you want to come up with. So there is not like one perfect solution that we all have. There are like different solutions, and all of them may actually be valid. And it's up to you to evaluate how concrete, how realistic is your solution compared to the data that you will have calculated from the previous task. So all this information that we give you right now is more to give you like some kind of background information, but all the assumptions and all the equations that you will need to use are actually given in the PDF file in the Moodle of the course. If you have like any questions, obviously you are like very welcome to come and ask. And as we have like 3 weeks to do this part of the project, at the beginning of every project session, basically we will go through like all the questions that you may have had like the week before. So if there are like some questions that a lot of you are asking because it's unclear, we will discuss them at the very beginning so that everyone can follow in the process. There is also like a MATLAB file and the Excel data that you will need for this project, but we strongly recommend you that you start by reading the project description, because the MATLAB file basically is like very basic, and if you just start with the MATLAB programming without actually knowing how the project is actually working, it might be a bit challenging for you in the process. Is there any questions so far? Cool. So we are here and we have like 2 rooms that are reserved for the projects. I suggest that the people that don't have a group yet try to get in a group. You can be up to 6 people. And there is like all the description of the project. And as soon as you have like a complete group, please come to us, and then we can give you like a list of buildings that you're supposed to analyze. Each group should analyze like 4 buildings out of all the buildings of EPFL. Understood?
Do you have a list of the list